Well, Unit 4, Lesson 7 is about the matrix exponential, and you're asking, what is a matrix exponential? And that would be, I would ask you to recall that x prime equals a times x, where x is a function and a is a constant, has general solution x equals constant times e to the constant a times t. That was something you proved back in Unit 1, maybe the first of the separable equations we solved. Or maybe I had you solve it. But a natural question is the homogeneous system of equations, vector x prime equals square matrix A times vector x, does that have a similar solution, vector x equals e to the at times c for a matrix A and a vector c? And of course that raises the question, what on earth is e to the matrix A times T?
I think our genius ain't appreciated here.
Well, that may be true, but what on earth is that? And that is something called the matrix exponential.
What's the big idea?
Well, the big idea is this. For any n by n matrix, the matrix exponential is e to the at, that's a notation for it, is an n by n identity matrix plus matrix A times T, plus matrix A squared times T squared over 2 factorial, plus, well, A cubed times T cubed over 3 factorial, plus finally A to the n times T to the n over n factorial. Look, notice how similar that is to just e to the at, right? Where a was a constant. It's the same thing. One little notational thing, a to the 0, you have to assume that of course that would be 1 if a was a number, but a is a matrix, so a to the 0 is an identity matrix instead of a 1. That's kind of like 1 in matrix land, if that makes some sense. So, note, if you took the derivative of this, right, then of course the derivative of the constant 0, the derivative of a times c is just a times 1, and then plus the derivative of this one would be a squared times t, and then you could go on down the line. You would probably be able to see that if you factored an a out of that derivative, you would have a times e to the at. And so this matrix e to the at, in fact, behaves just like this does. See? The derivative of this matrix exponential is a times the matrix exponential itself. So therefore it's obvious that e to the at is a solution to this homogeneous equation. Therefore the matrix is a fundamental matrix.
Now don't make any more mistakes.
I won't.